Good afternoon, ladies and gentlemen of Precalculus. We are starting to work on our trigonometric ratios. We actually started yesterday. And here, let's identify all these sides of this triangle. What are going to be our sides? What do we label these sides of this triangle? What are the possibilities for sides labeling? There are three words that are definitions for sides of a right angle. What are they? Hypotenuse. Okay, very good.
Which is already the 8.
So this one is your hypotenuse. And I'm just going to abbreviate that like this. Okay, what other sides do we have here?
Opposite
And which one is that going to be?
to the right.
So if you draw an arrow opposite the angle here, this will be your opposite side. And then by process of elimination, this side down here is our adjacent side. So what it is, our trigonometric ratios are sine theta equals what?
Can you say that little thing again? It's like
No, can you say it? I asked, can you say it? Because we did it, we made a big deal about it. Can you say it, I asked you. What did we say yesterday?
some old
Becky. Go ahead, what did you say?
some old hippie.
Some old hippie, okay. So here we are. So there we are, some old hippie. So what goes up, what goes here?
Caught another hippie trigonometric.
Very good, very good, very good. We're going to come to that. So that's A over, what is our hypotenuse? 8. So that's that. Okay? Some old hippie opposite over hypotenuse. Okay, Justin, did you say that?
Yeah.
Caught another hippie, okay. So what's cosine going to be?
Adjacent over
B over 8, right?
yeah,
Okay. And what is our tangent going to be equal to?
opposite over adjacent.
A over B. Okay, and then what are going to be our reciprocal ratios? We have CSC is going to be equal to.
Hypotenuse over.
So what you do if you write sine, all you have to do is take the reciprocal of that. So we just need to write this as 8 over A. And then our secant is going to be reciprocal of our cosine, which is going to be 8 over B. And lastly, our cotangent is going to be B over A. Okay, so those are some ratios worked out. And I want to tell you something that can be very helpful to you is if you're looking at an angle, and this is a real world example, if you're looking at, let's say you're standing looking at the edge of a building here, and you're standing looking up at an angle of 37 degrees, what this is, what other thing did you learn in algebra that's related to tangent? Anything you learned in algebra 1, that's related to tangent? It's related to algebra 1. Okay, it's in the song. Remember the algebra 2, those of you in algebra 2 last year, the song, the class song?
Oh wait, I wasn't in that.
You weren't in that class? Yes. You should be in class, but you have to do something.
Okay, what?
I don't remember the song.
See that?
A long, long time ago.
No, I know what song you're talking about. I don't remember the lyrics.
I once had a teacher who had taught me how to graph a line, but now over a year has passed, and my mind is filled a mess with summer memories that aren't mine. But now we're back in school this session, and I've got a sad confession. My skills dropped a big step. Fractions, a lost concept. But Algebra 1 has been so long. That's what we're talking about here, Algebra 1. But that's why my teacher sang this song, because when he saw my work, it was all wrong. So for now, I'm going to sing this song. Where do I start my line? Find the y-intercept and things will be fine. You need to find your points one by one, so you use the slope. It's rise over run. And that's what tangent is. Tangent is rise over run. Yes, it is. Rise. Tangent is rise over run. So really the tangent is the slope. So you're looking, if I'm looking out here from this building going up, this angle here is the angle of the slope. Rise over run. Does that make sense? So that's it should be a geometric connection. And the next image is really going to show that. I hope. Next image, please be there, please be there. Here it is, yes. What happens is we have the height, and we have this side here, this 340, this is our adjacent side, and then our opposite, h is our opposite side. So what we can do is we could say the tangent of this angle, 65 degrees, is equal to the height of the building over 340, our adjacent. So we have an equation we can use to solve for the height using tangent. And this is probably the most common real-world application of trigonometric ratios that we're going to use this year. Okay, so, and then to do that, you got to make sure your calculator is in what mode? Calculator has to be in degrees to use if you're using angles in degrees. Okay, so let's go ahead to, we're not going to solve that right now. We could, but we're not going to. Okay, now we're to the exercise set. We're going to go over, and this brings us to our exercise set today. I'm going to hand out the assignments to be working on today, which are right here. And we have 18 of these here today, so I don't know if we probably won't be able to get through all of these. We'll get sort of a good start, I hope. You ever heard the rise over run song before? You ever heard that?
I was trying to
These
remember.
four.
No, the other one too. Say the other one. Oh, the story of the day that I died?
Oh, the story of the day that I died. So that's a non-math related one.
Yeah, but he sang that one, like.
Did I sing that one this
Yes.
class?
Yeah, I do.
Did I sing, I haven't heard the story of the day that you heard that?
Will you sing it for us?
Oh, yeah, I'll sing it sometime, when there's time. Maybe today, since it's,
Why not today?
yeah, today might be a good day for it. We're gonna see if we have time. I think we will. We'll need a couple minutes for it. But I don't know, people like that song. I guess people like a sad story. I guess bad news sells, right? Isn't it pretty sad? I think it's pretty sad. Oh, you like the end of the song? Okay, all right. Okay, well here we have our problem 1. And the first thing I do is look for where the symbol is that we're trying to solve here. And I'm going to go over here to this side. And there we go. And I'm going to label this side over here our opposite side. And then this 5 over here is going to be our hypotenuse. And this 3 down here is our adjacent side. And so we want all 6 trigonometric functions And I like to use the word ratios instead of functions here. And why do I like to use the word ratio? What does the word ratio remind you of?
A fraction.
A fraction, right? So I'm trying to, in saying ratio, I'm remembering that, oh, it's something divided by something. The word function doesn't exactly convey that. So the sine is equal to our opposite over our hypotenuse. And I know that our reciprocal ratio, our cosecant theta, by the way, in your ACP formula charts, you have these reciprocal things. So if you have trouble remembering which reciprocal ratio goes with what, you can look at your ACP formula chart. And what it'll do is it'll tell you that the sine theta is equal to 1 over cosecant theta. And what is going to be our cosine theta? Think of what Justin was saying earlier. 3 over 5. And our secant theta is going to be 5 over 3. Now, there's something else I want to tell you about secant and cosecant and sine and cosine. And our tangent is going to be equal to rise over run, which is 4 over 3. And cotangent is going to be 3 over 4. Now what happens is the absolute value of cosecant theta has to be greater than or equal to 1. Has to be greater than or equal to 1. Okay, the absolute value of sine theta has to be less than or equal to 1. So these are always going to be greater than 1. These are always less than 1. Similarly, for secant theta and cosine theta. Okay? So look for that. Look for that. These have to be greater than or equal to 1. These ones here are less than or equal to 1. Okay, any questions on that? Okay, what I want you to do is go ahead and work out problem 2. And I'll go over that with you in just a couple minutes, okay? You can do that. You can work out problem 2. Basically, you should be able to work out problems 1 through 4. It's 5 starts throwing in a little bit extra.
I can't even read what this
You can't have trouble reading on the paper.
is. It's like B113.
This one right here is the square root of 113. That's what that is. Okay, that's what that is, yeah. Enlarge these. Okay, this one right here, I'm just going to show you what I have here. So sine theta is going to be equal to our opposite side, which is 8. So 8 over our hypotenuse. So is that what you got for your sine? Okay, cosecant theta is going to be equal to the reciprocal of sine. And then our cosine is going to be equal to our adjacent, which is 7 over our hypotenuse. And our secant is going to be our reciprocal of that, which is going to be square root of 113 over 7. And then we have tangent theta, which is equal to 8 over 7. And cotangent theta is equal to 7 over 8. And so that's it. Any questions about that? Did I make any mistakes on that? Okay, what I want you to do is do number 3, and then I'm going to pick a victim to do number 3 for us. How's that? And let's see, what else am I going to do?
Not with you, Roberta. It is going to be you. Actually, that's the
What do I want to do here? I'm going to give one of these to. Yes, I forget what it was. Oh, yeah, so it would be very good. Okay, let's go. All right. We got to be careful where a theta is, or theta's over here, right? So number 3, our opposite's going to be down here. Did you see that? Hope you did. Anyway, I'm going to call on somebody. Jada O'Reilly, it's going to be Jada. It's Jada. Jana, this wheel likes you. I mean, what can we say? All right, do you have this?
Sine is 12 over 13. And 13 over 12.
So there's your sine, and so your cosecant, you said, is going to be 13/12.
And cosine is 15 over 13. And also is 13 over 5.
And then your secant, you say, is going to be 13/5. And then tangent theta
12 over 5.
equals 12/5, and cotangent theta is 5/12. Okay, does that look right? Yeah, it looks good. One thing to watch out for that you'll see sometimes on tests and so forth is sometimes you'll see answers put into decimal form. Like this one right here, 12 over 5, that's 2.4. So you could possibly see decimalized answers depending. This one here, secant theta, is going to be 2.6 if you decimalize it. So just something to watch out for. And that's really it. Okay, thank you. I'll give you credit for that, Jana. Good work. Any questions on this? And one thing I like that over the years, okay, I've been doing this a long time, that a big mistake people make is they say, well, they picked theta at the wrong place, but she picked it at the right place. That is good work. Okay, let's go ahead to number 4. There's number 4. And here is our, who's going to help us with number 4? It's going to be
Roberto.
Elizabeth. The Elizabeth. They'll be able to come and give them credit. All right, Elizabeth. What I'm going to do here is I'm just going to go ahead and just write these. And I will tell you, there's another mistake people make a lot, and I'll show you what it is. Some people instead will just write cosine equals. I see that a lot. What's wrong with this statement?
There's no theta.
No theta. Okay, you need to have the statement doesn't make any sense unless you have some kind of a variable in there. And then we have secant theta equals. Okay, do you have this yet, Elizabeth? Okay, go ahead.
Sine can be 8 over 17.
8/17, okay.
17 over 8.
17 eighths.
No, actually, 15 over 17.
15 17ths.
17 over 15.
17 15ths.
And then 8 over 15.
And cotangent theta.
And 15 over 8.
15 eighths. Okay. Now, the next little set, 5 through 8, they're similar, except what's wrong with 5 through 8?
They're all missing variables.
Yeah, they're missing a side. So you're gonna have to do a little extra work on 5 through 8. Are you ready?
Good now, they're all square roots. You're thinking, if you square root it in the decimal.
I don't remember how to find this variable.
A squared plus B squared plus C squared.
Yeah. That's part of the reason we had our exercise the way we did yesterday. Alright?
Yeah,
That's what we're remembering. I want you to think
Thank
one day.
Elizabeth. Try to pay attention.
I know she's paying attention. She's paying attention. Another thing she do, she's paying attention. Another thing this year, I don't know what happened to her, but she's much more organized this year than she was last year. Is that true? Are you better organized this year than you were last year? So. But we all have things we can work on to improve. That was some good work. Okay, so what I want to do for number 5 is I can work it out, or I can choose somebody to work out number 5. What do you want me to do? I'm going to choose someone.
Pick me.
So right.
No,
Okay.
actually, just can we pick Roberto?
Riley says she wants to be chosen, so
Then it's
maybe
Roberto.
be Justin.
Justin.
Right, Justin.
I'm still working on it.
Okay, Justin, here's what I want you to do, Justin. I want you to, Justin, instead, I want you to do number 6. I'm going to call somebody else to number 5. So Justin, you got number 6, okay? You got number 6?
Yeah.
You'll do number 6, someone else will do number 5. And that person will do number 5 is going to be someone else besides Justin. It'll be Becky. Okay, Becky, you have number 5? All right.
So the hypotenuse would be square root of 170.
So hypotenuse is going to be equal to
Square root of 170.
square root of 170. Okay, let's just mentally do that pretty quickly. So 11 squared is 121, right? And 7 squared is 49.
49.
So 49 plus 121,
Is,
100. So that looks good to me. All right, Becky, go ahead.
So the sine, I don't know, is 7 over square root of 170.
Oh, we gotta do that.
Cosine is 11 over square root of 170.
I don't have room for that.
Okay.
Tangent is 7 over 11.
Oops, I don't know what that was. Okay,
And then when it's split, it's in 170 over 7, square root of 170 over 7. And then the next one is square root of 170 over 11. And the last one will be 11 over 7.
okay,
Golly.
does that look good? All right, Justin.
Yes, I got it.
All right, thank you. All right, Justin,
Number 6,
number 6.
the adjacent is square root of 28, right?
Okay, we have c squared minus a squared equals b squared, right?
Yeah.
So it's 64 minus 36 is 28. The square root of that, okay, is square root of 20. Okay, good work. All right, what do we have next? So here's your hypotenuse. Here's your opposite. Okay, so what do we have here?
The sine theta is 6 over 8.
Equals 6, 8.
The cosine is the square root of 28 over 8. And the tangent is 6 over square root of 28.
Okay,
What's the other one?
okay, cosecant
Yeah. 8, 6,
equals 8, 6. And then our secant is 8 over square root of 28. And then our cotangent is
square root of 28 over 6.
okay, one thing you'll see sometimes, you can do it in this case, is you can simplify this 6 over 8, right, to be 3/4. And this could be 4/3. Another thing, we haven't talked about this yet, but what you have is sometimes you'll see situations where it's sort of a convention in math that they don't like to have like a square root in the denominator. So what you can do is you can rationalize this by multiplying by square root of 28 over square root of 28. And what you get for this is you have 6 square root of 28 over 28. But to me this right here is a perfectly fine answer, 6 over square root of 28. But sometimes you'll see it what they call rationalized. Have you ever seen that before? To get the radicals out of the denominator. All right, very good. What I want to do, I'll give you So it was Elizabeth and it was Becky, right? It was Becky and Justin, yeah. Becky and Justin. Okay, number 7. Let me get somebody from number 7. Okay, number 7. Seven is going to be done by Robert Cole. All right, Cole, you have number 7? Great. Go ahead.
A squared plus b squared plus c squared, and then h squared plus 64 equals 121.
So you said 8 squared plus a squared, or b squared, excuse me, equals 121. And then,
It would be 64
so 64,
plus b squared equals 121.
okay.
And then sine is, wait, the sine, yeah, sine beta is square root of 57 over 11.
What did you say?
Square root of 57.
Square root of 57 over 11. So you're saying this right here is square root of 57.
Yes.
So you subtract, she gets b is equal to square root of 57 is what you're saying. Okay, good. Let's continue.
And then cosine is 8 over 11. And then tangent is square root of 57 over 8.
Okay, looks good. Then your cosecant
11 over square root of 57.
will be 11 over square root of 57. Your secant is going to be 11 eighths. And your cotangent
8 over square root of 57.
equals 8 over square root of 57. Okay. That's not too bad, is it? Yeah. Thank you. Okay, and okay, I'm gonna call on somebody for this, but first, what do I do? Here we go. Here. Okay, this next one is going to be, oops, here we go. We don't have a lot of people left in the mix.
Robert. Robert.
Oh, okay. What do you got, Robert?
With extra things. Okay, so opposite is square root of 80. I mean,
I'm thinking 9 is our opposite here. That's what that looks like to me.
adjacent.
So our adjacent is what?
Square root of 88.
Square root of 88. Okay, that's going to be 169. Right? Yeah, okay.
like sine theta equals square root of 88 over 13.
I didn't get that.
Over 18?
Or 13.
Wait, what?
The sign will be the opposite over minus.
I got 9/13 is what I got.
Oh, yeah, no, that's different.
Did they confuse you with the placement of this thing?
Yeah, they did. They got it.
Okay, so fix it. Tell us what it is.
You say sine?
Okay, square root of 88 over 13.
This one here?
Yep.
Okay.
And tangent equals square root of 88 over 900.
Okay, and then your cosecant is
13 over
13/9. And then our secant's going to be
13 over square root of 88.
square root of 88. And then our cotangent is going to be,
Square root of 88 over 9.
so that's, we have that. We're sort of running a little bit low on time. I want to tell you that we're going to go on these starting at 9, on 9 tomorrow. And basically with these here, the best way to do it is kind of sketch something. So we'll just be ready to work on those tomorrow. How's that? Are we okay on that? Okay.